We're going to do 5.5 using inequalities in a triangle. This is easier. When you see inequalities, don't freak out. It's much easier than what you did in Algebra 1. You're still going to solve inequalities, which I thought was the easier part. The hard part of Algebra 1 inequalities was the shading the graphs and graphing it and stuff like that. What's the unique thing about inequalities versus equations?
Equations equal something.
Okay, equations equal something. Okay, but what about solving? When you're talking about solving inequalities, what's unique to that?
There's like a whole range.
There is more than one answer. There's a range, but what else? Is there something different when I solve inequalities versus equations?
You get shade.
No. There we go. That's what I'm looking for right there. This is the thing that you need to hear right here. Say it again. Yeah, if you divide by a negative, you flip the sign. Okay, that's the one thing that you need to focus on. Shading is not going to be relevant to this particular section. The range of answers will be. You'll see that here in a second. But ultimately, you just got to remember if you divide by negative or if you, for some reason, you multiply. I don't know why you would. But if you multiply by a negative, same thing. Okay. So let's take a look at our triangle here. We have triangle ABC. Measure of angle A is 59 degrees. Measure of angle B is 73 degrees. Measure of angle C is 48 degrees. Okay. A couple sections ago, we learned that isosceles triangles have what? Okay, two congruent sides first is the definition, right, of isosceles. The two congruent angles that Marilyn just told us about, those come from that theorem that basically showed that if the two sides were congruent, the two angles were congruent. What two angles in relation to the sides? Yeah, opposite of the sides. The two angles opposite of the congruent sides were also congruent. That is not by coincidence. That's by design. Okay? You're going to see that happen on a regular basis. The angles and the side opposite from the angles are directly related. Okay? They are directly related. So if you look here, look at the side across from angle. Well, first of all, tell me the largest angle. 73, which is angle B. Bless you. Okay? Now, let's look across from angle B. Okay? What do you notice about the side across from angle B? It's the longest. So our longest angle goes with our longest side. Okay? Just like our smallest angle, which is what? 48, or angle C is across from our shortest side, BA, right? BA being 10. Okay? So that's the one thing that we're going to pick up from, one of the things we're going to pick up from this section is that the longest side is opposite the largest angle. The shortest side is opposite the smallest angle. And if you think about it, that's kind of common sense. Okay? And most of you probably haven't thought about this in depth enough to understand that. But carpenters, architects, people that work building stuff, they think about this all the time. So let's look here. If I have this, and this is roughly 60 degrees, okay? Notice the distance between the two tops, right? Let's just say it's 6 inches, hypothetically, okay? The only way that 6 inches is going to change is if I change what? The angle. So if I make this angle smaller, notice what's happening now about that gap. That gap is doing what? It's getting smaller also. So my angle's getting smaller, and my gap is getting smaller, right? My angle's now getting bigger, my gap is getting bigger. That makes sense, right? Okay? And it's important to understand that. And also engineers. Those of you who want to be like engineers, structural engineers, stuff like that. If you want to, angles is what helps us support, right? If I haven't, we talked about this earlier, we have, tripods are better than the seats that you're in, right? Because it's all on one plane and stuff like that. Well, angles, when you start talking about angles, certain angles will give you more strength, right? And so if you have to change an angle for whatever reason to give you more strength, or because it's a decoration or it's an artistic architectural structure, then you have to determine, okay, if I change that angle, how much is that going to cost me in material? Because when you deal with building stuff, and you deal with architecture, and you deal with all that kind of stuff, you have to factor in all those things. So when you start changing stuff, just by simple little angles, you either increase or waste material, right? So that's something that you need to know. So that's pretty simple. Largest side, largest angle, shortest side, shortest angle. Okay? So here's what we're going to put these these sides in order from longest to shortest. Okay? Well, what do I need to do first? What?
Find the other
Yeah, I need to find the other angle, which is angle what?
D.
D. Okay, so 75 plus 63 is what?
42, I think. What? Like
I know
the-
where you're
the
at, but
angle.
75 plus 63 is what?
138.
138. So angle D, Charlie, is
42.
42. So angle D is 42. Okay? So we added those two together, subtracted from 180, we got 42. Now, I want to put this in order from longest to shortest. Okay? So, what's the longest side? FD.
D.
Because? Because angle E is the largest angle, so the largest side must be across from angle E. It's FD. Okay, what's the next largest angle? ED, and then the last one? FE. Now, this isn't like your elementary school where we put it in the largest to greatest, or greatest to smallest, or whatever, and say, okay, FD, ED, and EF. No, instead, you have to put it in the proper notation, and it looks like this. FD is greater than ED, which is greater than FE. So you still go ahead and list it like elementary school, but then I'm going to throw in my inequality signs, right? And notice, when I'm dealing with largest, what is my inequality sign?
Going left.
What's it
Greater
called?
than.
Greater than, right? Greater than. So FD is greater than ED, which is greater than FE, right? And that makes sense, right? Okay. Any questions on this part? Okay, let's look at the bottom one. Okay, now we're going to put the angles in order from smallest to largest. Okay, well, what do you think? Smallest to largest now.
Angle J.
Angle J, why?
Because 10 centimeters.
Yeah, it's across from 10, which is the smallest. Okay, then what? Angle H, because it's across from 13. And our largest is G, because it's across from the biggest side, right? And again, write it down like that. J, H, G. Now I'm doing smallest. What kind of sign do you think I'm going to have? Less than. And there it is. Angle J is less than H, which is less than G. Make sure you write it in the proper order. This is one of those questions on the test. If you don't slow down, you lose points because you didn't read it in the right order. You didn't write it in the right order. Even though it's right, you didn't put it in the right order. That's key. Okay, any questions on this? Does everybody have this? Everybody ready to move on? Super. Let's go. Okay? Now this is where I know some of the regular geometry students, when I'm dealing with them in past, this is where they struggled a little bit. It's kind of complicated. If you're given three side lengths, it wants to know, will it make a triangle? Will it make a triangle? Okay, let's look here. What do you think about 2, 3, and 5? Will that make a triangle?
Yeah.
Okay, let's bring down 3 to 2. Now remember, a triangle, in order for it to make a triangle, it has to be what?
3 sides.
3 sides that do what? That connect, right? They have to enclose, right? Did I actually touch the other side?
No.
No, I just barely missed it, right? But if I keep going, and I bring this one down, do I touch now? Yeah, but because they're the same length, right? But if I give any angle to that, it won't touch at all. They'll just go right by each other until you get down to where they're right there meeting. Does that make sense? Okay, so that doesn't make a triangle. We end up being stuck right there. What about this one? 4, 5, and 8. Think that'll work?
Yes.
Let's move 4 up. There we go. Sure does. It overlaps with the other dot, doesn't it? Okay, so that is a triangle. What about 2 and 5 and 9? No way, right? No way that's going to reach ever, no matter what I do there. Okay? So, make a conjecture. What do you think?
Adding the other 2 lines has to be 1 or more bigger than
No one side can be bigger than the other two.
Okay? She said no one side can be bigger than the other 2. Charlie was saying that if you add the 2 sides together, it's got to be 1 more than the other one.
At least.
Which is exactly the same thing. Does it have to be 1 more than the other one?
Or one less.
No. No. No.
Not 1 less.
Randall, look at the bottom one.
But what I'm trying to get you to understand, though, is this. Okay? you always work in increments of 1.
0.1.
Can it be 0.1? Can it be 0.001? It just has to be what? Greater than. So what she said takes what Charlie says to another level and makes it more clear. So realistically, this is what it needs to be. The sum of any two sides has to be greater than the third side. So it can be 0.1 or 0.01 or 0.001. Now you're not going to deal with numbers that small, but it can be, right? Is going to help us figure this out. Are these side lengths of a triangle? How do I know? So 5 plus 7 is greater than 10.
7 plus 10 is greater than 5.
7 plus 10 is greater than 5.
5 plus 10 is greater than 7.
5 plus 10 is greater than 7. All three of those must work. If any one of those does not work, it is no longer a triangle. The easiest way to do this is to write down 5, 7, and 10 on the outside of a greater than sign, and then write the other numbers left. You'll see why that is easier in just a minute. So all the combinations there work. What about this one? 2, 9, and 5. No, why? So 5 and 2 is not greater than 9 or is less than 9. Okay? Whoops, wrong button. Now look here. There's a shortcut you can kind of take sometimes. If the two smallest sides are not greater than the largest, that's when it's going to show you that it's not a triangle. Okay? So to measure 9 and 2, add 9 and 2, and to add 9 and 5, that's kind of a waste of time. Okay? So you can measure the shortest ones first to determine quickly if it's going to be right or not. But you still have to prove all three sides. Okay? But I can add those two short ones together to show the two smallest sides added together have to be greater than the largest side. Because that's where it's going to be if it doesn't work. Okay, any questions on that? All right, let's throw in our algebra piece here. Yes! Here we're given a triangle, and it's clearly a triangle because you have three sides that are enclosed, right? That create an enclosure. Okay? Now, if I want to find out the x value that makes these triangles work, okay, I'm going to do the same thing. I'm going to take my three sides, 5x minus 9, 2x plus 10, x plus 11, write them on the outside as a greater than sign, and then go ahead and put the other two sides there. And then what do you think I'm going to do? I'm going to solve for x, right? I'm going to solve my inequality for x. When I solve this inequality for x, I'm not going to go through that process. But when I solve this inequality for x, I end up with x equals 15 is greater than x. So right now, based on my work, I can say that my x value must be less than 15. So any number less than 15 at this point in time will work for that to make those triangles. But if I continue to work, because I got to do all three, I'm going to find out that x has also got to be greater than 2. So I'm creating limits now. One of my limits is x has got to be less than 15. One of my limits is now x has got to be greater than 2. Okay? So any number at this point that's greater than 2 and less than 15 will work. If I solve the third one, I end up with this. X is greater than 5/3. Well, what's wrong with that one?
Doesn't equal. It's smaller than 2.
It's smaller than 2. So I can go ahead and throw that one out. It doesn't mean I don't have a triangle because I clearly have a triangle. I can see it, right? It just means that this one right here isn't going to help me. This 5/3 because it already does not meet the other limitations. So that means my answer must be what? Sum that up for me. Based on my work, my x value must be what?
Between 2 and 15.
Between 2 and 15. So it's going to look something like this. I'm working on it. There you go. My x value is going to be between 2 and 15. So 15 is greater than x, which is greater than 2. All right, last but not least, what if we wanted to find a third side that we didn't know? Let's say we had 5, 8, and x, and I want to find that third side. What would I do? 5 plus 8's got to be greater than x, right? 5 plus x has got to be greater than 8. 8 plus x has got to be greater than 5. Okay, and then I still solve those, and when I solve those, I end up with those numbers.